I think that we can start. We are just in time. Welcome to everybody. I am really very pleased and honored to introduce Francesca ROSSI for her invited to talk at this conference. Francesca, for those of you who don't know her, is an IBM fellow and global leader for responsible AI and AI governance at IBM Research. She's speaking from your town, I believe. And she has a very long background of research, successful research in theory of constraints, computational social choice, and neurosymbolic AI, and governance of AI. She has covered very prestigious positions in the past. She has been president of each CAI, editor-in-chief of the Journal of Artificial Intelligence Research. She is in the board of the Partnership in AI and is co-chair of the expert group OECD AI Futures. She has been president of the Association for the Advancement of Artificial Intelligence from 2022 to 2024. And to me, she is a dear friend and an old friend of mine. An old friend just because I am old, but she is very young. So today is a pleasure to be here, and I'm again very honored to be here and listen to you. Thank you.
Thank you, Gigina. Can you all hear me? Can you all hear me? Yes? Okay, thank you. Thank you, Gigina. Thank you for the organization, for the invitation. I'm really sorry I cannot be there in Rome with you. Let me share my screen so that I can show you my slides. Okay, can you see my whole screen, the presentation? Yes. Okay, so today I will to give you an overview of this landscape of AI ethics and governance, and to also a perspective of a company, of course, that is a technology company, so builds AI technology, builds systems based on AI technology, but also uses it and then delivers these solutions based on AI to our clients, but also uses AI internally. So the first thing that I would like to convey to you is that AI evolves very rapidly. AI capabilities are really evolving a lot and has been evolving for the last 30 years. And so the first message is that, of course, not all AI technologies raise the same ethics issues. And as AI evolves, these ethics issues evolve as well. So whoever is looking at this AI ethics landscape needs to know that the issues evolve, they are amplified, or they're completely new with new AI capabilities. So it is a very dynamic environment where new ethics issues come up and need to be addressed, first identified, then understood, then addressed in some way. So let me give you a very short overview of the history of AI for the last 70 years. AI has been started conceptually even earlier, but the first time that this term was used was in 1956, so exactly 70 years ago. And here I just put a picture of some of the main waves of AI capabilities. First, from the left, rule-based symbolic AI, where we were telling machines how to solve in an intelligent way a problem by giving the steps that were needed to solve the problem. So the developers were understanding themselves how to solve the problem, and then they were coding those steps into a machine. The typical example is the step-to-step by step algorithm that is at the base of our navigation systems, for example. Then the second wave is the, let's say, right now, more traditional machine learning or narrow machine learning approaches, completely different way compared to the rule-based approach to telling a machine how to solve a problem, not by telling a machine the steps to solve the problem, but by giving the machine a lot of examples how to solve a specific problem, and then letting the machine learn from these examples to solve also problems that he has not seen in the examples. And then machine learning, of course, evolves over the years, becoming more and more capable, and it evolves into what people call deep learning, which allows to tackle more complex problems like identification of a face or interpretation of vocal commands, but still focus on solving one specific problem at a time. Then the wave of generative AI, like what we found in large language models, for example, is instead still based on machine learning approach, so learning from data, but this time is not a narrow approach. It's not learning to solve a specific problem, but is learning, for example, large language model, a very abstract thing that does not relate to any specific problem, because generative large language models just are trained to learn from data, which is text, to learn how to generate one word after another one, given the words that it has generated before. But this very general learning task is enough to be able to generate text in our language that can be reasonable responses to many of the questions that we may have, or many dialogue that we can do with these machines on many different topics. So much more general than traditional narrow machine learning. And then agentic AI, the latest wave, which is not really like the other waves, bringing a new way of teaching machines how to be intelligent, but it's a new way of combining different AI techniques and delegating to these AI systems some of the tasks. So now, while generative AI or large language model, they are suggesting what we can do to solve a problem, agentic AI may actually execute these actions that directly. So if we delegate them the execution of these actions, okay? So I'll give you this. I gave you this sequence of stages in machine learning, but of course, it doesn't mean that the previous techniques are not used. They are all used at this point, together or in combination or one. Each one in isolation, but to tell you that each one of them brought new and or amplified ethics issues. So the rule-based symbolic AI techniques, actually, they didn't raise any really significant AI ethics issues, because in this situation, in this kind of techniques, we were sure about the behavior of the machine, because we were telling the machine exactly what steps to execute, like in this example of the algorithm that is one of the ones that are the basis of our navigation system. And so everything is traceable. An output that comes out, it can be traced back from the input. It's not driven on data. And so there is an abstraction usually of the world, but this abstraction is defined by the human being writing that piece of code, and that abstraction is chosen in a way that is enough to make good decisions about that state of the world and whatever is the problem that we want to solve. So here we didn't find really any significant AI ethics issues. But when we go already to what I call a traditional machine learning, narrow machine learning, not generative AI, we start seeing a lot of AI ethics issues. So the first and most of the issues have to do with the possibility of these machines and their behavior to impact on important human values in a possible risky way and not desired. So the first thing is that these machines, as I told you, using machine learning techniques, are learning from data, and they need a lot of data to learn and to be able to learn how to behave in the best way. So the data needs to be shared with the machine, and so there are issues about data privacy and governance, so that are really central to the way that these machines are built. Then another second issue is very important, is the issue of fairness, because learning from data, this training data can hide some correlation between different variables, like the gender of a person and whether the loan application can be accepted or not. And there may be correlations that are hidden in the training data, but then the machine can find them and use them to make decisions or the recommendations in a way that can generate discrimination. So there can be a risk of impacting on this important value of fairness, so that everybody should be treated in the same way. And also, these machines can learn from data generated by people, can profile people, and even manipulate their preferences. So the issue of the impact on human and moral agency. The next one is explainability, and this is important because compared to rule-based approaches where everything is explainable and traceable from the output to the input, here instead this is not the case. So these AI systems are often opaque, and it's not that easy to understand why a certain output was generated given the problem instance that is given at the input. So explainability is the property, the capability of the AI system to explain why it has behaved in a certain way, why it has generated a certain output. Transparency sometimes is confused with explainability, but transparency is a very different concept, which has to do with the behavior not of the AI system, but the behavior of the people building the AI system, that if they are transparent, they share the way that this AI system has been built, which tests have been done, which training data has been used, and so on, so that whoever is going to use it can use it in a more informed way, and therefore can distinguish between the most appropriate use, the intended use, and uses instead that should not be adopted because maybe they're not being tested on those kind of uses. So explainability is a property of the AI system. Transparency is a property of the behavior of the people building the AI system. Accountability is also another thing that comes about here, and this fact that systems that learn from data are based on statistics, and therefore they always have a percentage of errors. So and of course, the percentage of error, and these errors are not errors because some developer made a mistake in writing the code, but because, again, they are based on probabilities and statistics, and therefore they make decisions about generating output based on these statistics, and this means that they can make few mistakes. And you know, the training and the testing phases try to minimize this error rate, but there is always a small percentage of error. And the fact that we use machines that have a small percentage of error means that there is no rule-based system which can have 100% accuracy to solve the same problem. So they are needed, otherwise we wouldn't solve certain problems. But when the errors are made, then the question comes, who is accountable for that? Who is responsible for those errors? And then, of course, it starts being important also the impact on society, and in particular the impact on jobs, because these machine learning approaches that are specific to being able to solve specific problems can replace, or the execution of some tasks that were usually made by humans. So already traditional machine learning has some raising a lot of AI issues. Then with generative AI, so let's think about large language models, but there are a lot of additional AI issues or amplified AI issues. And here on the top right, you see a white paper that we published at IBM to understand these changes in the AI issues around what we usually are called foundation models. And the generative AI system are called foundation models because, as I said, they're very generic, they're very general. So they can be used as a foundation for building more specialized AI solutions. So the issue of privacy of the data, and here we already had the issue of privacy with the traditional machine learning, but here is amplified because these LLMs can disclose personal data in the content, in the text that they generate. And this part of the issue was not present with non-generative AI. Then the second one is value alignment. And so I already talked about fairness, which is, of course, a value that is important for humans. And already traditional machine learning, narrow machine learning, was giving the risk of not being aligned in some sense to the fairness value. But here there are many other values that can where generative AI cannot be not aligned with, because generative AI can generate content like text or even images or even videos that can be offensive, violent, biased. So fairness is included here because of the bias. But there are many other values that are important for humans that could be violated when this content is generated. The third issue is the culture representation. So these generative AI systems are trained, for example, large language model, over all the text that is on the web. And to learn, as I say, to generate text. But of course, this text that is on the web, the training data, does not represent all cultures equally well. No, the English language is more represented than other languages that are spoken by fewer people in the world, or even the culture, the norms on each culture or each community are not all well represented. And so therefore, there is the risk that when we use these large language models, we get answers that represent well certain cultures, but less well other cultures. And generative AI system put everything together that generates the most probable thing, most probable piece of text or toward one after another one. So that means that there is not really the ability to distinguish between these minority cultures or communities and the overall more represented one. The next two actually are about information that can be very realistic, but not actually true. And I distinguish these two things. One is misinformation. So the fact that generative AI system can generate very realistic information, but false. And these are the so-called hallucinations in technical term. And for example, a large language model can generate a piece of text which looks very reasonable as a response to our question, but actually contains false content, like false dates, false piece of information, false names, false references, and so on. So in this case, is the AI system that generates this false content, even if the user is not requesting false content. The user is requesting real content, but the AI system, by the way it's built, can generate this realistic but false content. The second one here is disinformation, where instead is the user of the AI system that can intentionally use the capabilities of the AI system to generate false content. And these are the so-called deep fakes, where, for example, AI system that can generate videos or audios or images that can intentionally ask the AI system to generate content that is false, like a video of somebody doing some bad things while this person never did that thing. So usually done to go to damage, for example, the image of a person, and of course this can impact democracy, elections, and so on. Then the impact on society here becomes even greater and amplified compared to traditional AI, because now more jobs, more tasks can be done by these AI, generative AI systems. So also those that have to do with creating content. Any job where we need to create content in a digital way can be accelerated at least, or sometimes even done completely by generative AI. But of course, it's done completely is always a bit dangerous, because again, the risk of hallucinations and of false information. So, but the impact on jobs is amplified, on jobs, on various activities, the impact on our relationship, because many people, especially young people, interact with an LLM more than they interact with their friends. The impact on our cognitive functions. There's been studies that show that if we interact a lot with this system, how in some sense we don't stress, we don't use our cognitive function as much, because we delegate a lot of the effort in solving a problem to this generative AI system, as well as the impact on mental health, because many people that are vulnerable and have mental health issues, they can not being helped, by interacting with the generative AI system, as well as the impact on environment, because these systems, again, are trained over huge amounts of data. Large language models are trained basically on all the text that is available on the web, and therefore they need a lot of resources for the training phase. And now they also need a lot of resources for the inference time, which is the time when we use the generative AI system after it has been trained. Because even in this interaction with the AI system, the generative AI system can do a lot of work in the back end before giving us the answer. And therefore, in doing that work, can also use a lot of resources. So let's go a little bit deeper about this issue of environmental sustainability. So, as I said, generative AI needs a lot of resources in training, in the fine-tuning, which is one phase of the training, to make sure that the AI system behaves possibly in a way that we want, as well as during the inference time, which is the time that we use the generative AI system. So a lot of consumption of energy, emission of greenhouse gases, a lot of use of water for cooling the data centers, a lot of generation of electronic waste, because these chips evolve, they change, they are, new chips are bought because they are maybe faster, and also old ones are thrown away. And so there are two things that usually can be done and are actually done by many. One is to prevent all this energy consumption, to mitigate it. And then the second one is to exploit AI capabilities itself to help with the environmental crisis. So to reduce pollution, to protect biodiversity, and so on. So, yeah. So, for example, there are many that create models, so large order models that are more efficient, they consume less resources, and that are also smaller, so they consume less resources because they are smaller. So they use less resources, or they use renewable energy sources, both in the training phase, fine-tuning and inference. So there are a lot of techniques that people have put in place to reduce the consumption of energy in these phases. Is a lot of work that is done also on the hardware that is needed to support these phases, the training, fine-tuning, and inference of these models, which generates hardware that is more and more energy efficient. And then there is also a lot of work in the uses of AI, for example, to optimize the energy distribution. So AI use to optimize and to mitigate mitigate the climate emergency. So optimize energy distribution and usage, address more in a faster way the power outages, make a better use of renewable power sources, and so on. So a lot of things can be done to mitigate and also to help with the climate one. The next phase that I mentioned is agentic AI, so where AI is now used in an advanced way compared to generative AI, because even if it's based on generative AI, it's not only used to give humans recommendations on how to solve a problem, but they actually solve the problem itself. So they not only give us a plan of actions, but they also execute some of those actions if we delegate them to them. And here you see on the left another white paper that we published to really understand these additional issues and how to mitigate them. And here you see that in this white paper there are two, big list of issues. Here I just mentioned a few of them. Some of them are new, really intrinsic to agentic AI, and others are instead amplified compared to generative AI. So the ones that are new is really the issues of autonomy and unsupervised autonomy, that we delegate the execution of tasks to these systems. Another new one that I want to highlight here is that hallucinations, we already knew hallucinations with the generative AI, but with agentic AI, the hallucinations also can have to do with the fact that a large language model hallucinates not just in the response given to the human being, but also in calling another tool to execute an action. So it can call the wrong tool, it can call the right tool, but with the wrong input. So hallucinations also plays a different role here, which is in an agentic AI system made of several components, tools, language models, and so on, in the way these components interact and call each other. Also, in these component-based AI systems, there are also more challenges in terms of vulnerabilities, security, robustness. So more ways, more pieces where people can attack, malignant people can attack the system and may exploit the vulnerability of the system for their gain. Also, if a system executes an action, these actions can be irreversible. Once you move money from one account to another one, you cannot move it back. So they can be, one thing is to give a recommendation to execute an action. One thing is to execute actually an action that can be irreversible and can be harmful consequences. Some of the issues are amplified. For example, more issues about the value misalignment that were already present with generative AI, because now the misalignment is not just in the text that we generate, but can be misaligned in these actions that are executed. More ways of being unfair, so having bias, because actions can be discriminatory. A lot of issues amplified about people over-relying, so trusting too much these AI agents and delegating too much, or under-relying, being very resistant to use AI agents because they're afraid of what they can do, so they just shut down and don't use them. And then an amplified issue here about actions that are executed, but we cannot trace back to why that action was executed. So the last part that here that I wanted to mention is the issue of how should we use these AI systems? Taking care, suppose that we take care of these AI some ethics issues, but how do we want to use these AI systems? And one important approach is to say, okay, we want to use AI system, but keeping in mind that here we want to help and augment human intelligence. We don't want to replace human intelligence, also because these AI systems are very different from how humans think and reason and behave. So the right way to use them is to complement and augment human intelligence rather than trying to replace them. And here, of course, the issue of trust, there are issues that are related to the relationship between AI and the human being that may use this AI system to do better what he or she does. So the issue of trust becomes central to avoid, so what is the right level of trust? How do you make sure that the human has the right level of trust in this AI system, not too much and not too little? And then what does it mean for humans to be in the loop of the final decision? And so what does it mean for human to be meaningfully in the decision process before an action is actually executed? So this idea of human oversight over what the AI is doing, that in some regulations like the European AI Act is regulatory requirements, for example, for high-risk use cases. But in general, even if it's not required by regulation, how do you build the right collaboration environment between the human and the machine? And here there is another white paper that we published to understand really what it means to augment human intelligence, because of course companies are interested in automating what machines can do better than humans, but in overall, you want to augment human intelligence to keep human in the loop. So that's why in this white paper, for example, we wrote a lot of KPIs for a system where AI collaborates with a human being. And some of them are traditional KPIs, like you want in this collaboration that the task is executed more efficiently, that the error rate is reduced, that you save costs, and the overall, at the end, the decision is better. But you also want to help the human involved in this collaboration to be involved in the decision process. So you want to amplify the learning capability of the human being, improve its decision-making capabilities and the problem solving, because these humans that can keep or amplify their learning capabilities and decision making, they can help in using this AI system in the best way, also for the benefit of whoever is putting in place this collaboration. So, what should company do about AI ethics? Because of course there are many actors in the society that should play an important role in making sure that these AI ethics issues are handled in the best way, like regulators, of course, but also civil society organization, but also each one of us as users. But a very important role is with the companies that build AI or use AI. And the reason why companies play an very important role, besides what regulation requires, is that regulation process is at this point very slow compared to the evolution of the AI capabilities. And therefore, companies cannot just say, I'll wait for the regulation and then I'll do what they ask me to do, because this is not agile and fast enough to keep track of all the issues as they evolve with the evolution of the technology. So if a company wants to put in place an approach to mitigate these issues, unfortunately, is not really that it has to put in place one thing, but it has to put in place an entire framework made of several things. Some of them may be technological, like software toolkits, but most of them are related to the people involved in building or using the technology. So from high-level principles to the identification of the issues that are relevant for that company, to the guidelines for developers, the risk assessment for every use case, education and training of the people, integration of all the processes, partnership with other multi-stakeholders, governance. So a lot of different things that a company has to put in place. And at IBM, for example, we have started many years ago with our principles, but then we built a board that makes decisions about responsible AI, and then we built the governance, internal processes that are integrated with all the other existing ones, and then we evaluated our solutions for our clients to be, aligned to our AI ethics principles. So these are our principles that we published several years ago. So again, the augmenting human intelligence, the data issues that for us are very important to how we treat the data of our clients, and then the transparency and explainability. And then we said, well, looking at our business model, which for IBM, for example, is that we deliver solution not to individuals, but to other companies. So it's a specific business model, which is different from the business model of other companies. We said, what are the issues that already in traditional machine learning are relevant for us? And we said, okay, they're explainability, transparency, fairness, privacy, robustness. And then we evolved with those white papers that I mentioned to understand the issues that are new or amplified with generative AI and agentic AI. And then we put together this, so who is making decisions and about AI ethics at IBM. And we said, okay, let's put together this responsible tech board that has representatives from all the business units, not just the technical ones, and that evaluates everything that the company does around responsible AI and then makes decisions. So important that it's not an advisory board that gives recommendations and then people can decide whether to follow or not. It is making decisions. So if the responsible tech board says, we cannot give this solution to this client because it's not aligned to what we think is responsible AI, then that deal is not signed. And this board again generates these white papers like the ones that I mentioned, and one of them is here on the left. But then from these white papers also transform the content of these white papers into platforms and tools that can be used for the solution to our clients. Like one of them is the so-called AI Risk Atlas that for every use case, it shows which are the risks that are triggered in the long list of risks like fairness, robustness, value alignment, all the ones that I mentioned before. And these can be used inside the platform, which is in this case called watsonx, that we use to build AI solutions for our clients so that the risks and their mitigation can be immediately identified in order to build a solution that is mitigating those risks best. This is a picture that shows this methodology that we trained our developers to build an AI model or an AI solution in a way that while building it, mitigates these AI ethics issues, whether it's fairness or explainability or transparency and so on. And so these steps that you see here, 1.1, 1.2, 1.3, and so on, they show that over these various phases of the building of an AI system, scope and plan, collect and organize, build and train, and so on, in each one of these phases, already developers were using these phases and we knew what to do in each one of these phases, but we added added, we trained them to add additional steps, the ones that you see here. Some of them are technical steps, like new tests for bias, for example, but some others are governance steps. Who nominate a person responsible for this, or record the results of these tests in a transparency fact sheet, and so on. So how to add new steps in the in the developing of an AI system to make sure that these AI ethics issues are not issues that are an afterthought. Why, when the system has been built, then you think about how do I deal with this AI issue, but you think about it and you do something about it from the start of the design and the building of this AI ethics system. So this is a list of toolkits that we put together to help these developers use this methodology, and supporting that methodology with tools, like there is a tool about explainability, another one about fairness, another one about robustness. And each one of them is a software tool that helps these developers achieve this, make these additional steps. But of course, the building of the toolkits is the easy part for a tech company. What is a little bit more complex is really helping developers understand how to use these tools, when to use them, what it means to use these tools. Like even the notion of fairness and bias was not really clear to our developers a few years ago, because they were not used to know what it means for an AI solution to not respect fairness, for example. So we needed really to do a lot about the training. Another thing specific to generative AI is that there are a lot of language models. Here you see a whole range of large language models that are available, whether it's from OpenAI or from Anthropic or from Meta or from others, IBM as well. And some of them are open source, so open weights, open. Some of them are closed, so we don't know how they are built. We only can use them, but not knowing how they are built. And some of them are very large. They use a lot of resources, a lot of data. Some of them are smaller. The focus, for example, of IBM is on the left part, so small language models specific to solving problems inside the company, not to answer questions about any topic by billions of people. And open source, released with an open source license, and also transparent, meaning that we are releasing a lot of information about how our language models are built and should be used. So they are called Granite, and they're now at the 4th edition. And they have, these are the specifics in terms of number of parameters and so on. But anyway, so they are on the small side for the large language models, and they are very transparent. For example, in 2025, there is a Stanford Transparency Index that evaluates every language model released according to the transparency of the reports of the documents that are released together with the model. And you see that our model, in particular Granite 3.3, because it was still at 3.3 and not 4 when it was evaluated, is at the top of the list. So we are releasing a lot of information. We want to be as transparent as possible to make sure that whoever uses our models uses in the right way, being informed about how it was built. We also use large language models, and this is true not just for IBM, but large language models can also be used to help with the limitations of the large language model themselves. For example, the so-called guardian models are language models that can intercept the input that we give to a language model or the output that comes out of a language model to check for content that is not aligned to our values, like biased content, violent content with text with profanity, with sexual content, unethical content, hallucinations, and so on. So this is really helping in making sure that the prompt that is given to the model is value aligned, but also what the output that generated the model does not have these issues that I mentioned here, including the issues of hallucination, as I mentioned, in an agentic AI framework, where the output of a language model can be the input of another tool or another model that can then execute an action. So if that output is not correct, it has an hallucination in the incorrect tool to be called, or incorrect parameters, or incorrect, then that could generate the execution of wrong actions. Another thing that we do is also the evaluating the use cases, no? And every time a team builds a use case for a client, we need to evaluate whether it's aligned to our responsible AI framework. And again, the board here, the responsible tech board, here is written AI at this board because it was the initial name of the board, reviews it and generates over time. We reviewed so many of these use cases that at some point we started abstracting from the evaluation of each use case and then giving general policies for each category of use cases. So this is an example of a use case that came to the board and was discussed. So it was using AI to take data about safety and maintenance of a product, and they wanted to fully automate safety reviews and then determine what actions were required for the maintenance. And the board identified some potential risks. So in the full automation, for example, in the lack of human in the loop involved in the reviewing and decision making, and the data quality. So we revised the use case to make sure that the system was not fully automated, but was making recommendation for a human being to review and validate. So AI used not to completely leave the human out, but to augment the human decision making and so on. So this is one example of how the board looks at the use case and then possibly changes it and asks the team to change it, and both the technology or the way it is deployed to make sure it's aligned to our system. And then we use a lot of enablers to make sure that these pre-internal processes are done correctly. So education, a lot of courses on trustworthy AI ethics, the AI ethics methodology, a lot of work in integrating these new processes around AI ethics, like the use case assessment, with existing processes. So, for example, our teams were used to follow some process for data clearance, security by design, privacy by design, and then we asked to add the ethics by design. And this was done not in an integrated way at the beginning. So the teams were confused, where we were asking redundant questions. So at the end, we understood that without an integrated governance program that triggers what to the developers, what they need to do for both security, privacy, data, as well as AI ethics, that we really enhance the adoption of these processes. And then,
Francesca,
go ahead.
We have run out of time.
Okay.
And unfortunately, we have another session after this one.
Okay.
So, please.
You want me to recap?
A quick conclusion.
Okay, quick conclusion. So I'll go very fast. So the last part, but I'm happy to share the slides so that people interested may look at it, is why should a company invest in AI ethics? And here there is the result of a study that shows that companies that take care better of these AI ethics issues also are more successful. So there is a return in investing in AI ethics. And then the overall takeaway. So evolution of AI ethics as AI evolved. Second thing, companies need to put in place a lot of pieces, not just principles, not just technical solutions, but a lot of other things. And the fact that there is a return in investing in AI ethics. And here there are some resources if people are interested, and I'll stop here. Thank you.
Okay. Thank you very, very much.